Hello, Steam Power. Welcome. It's Friday. You made it through the week. We're almost done. We have one more Steam Bytes workshop, and this workshop today is going to focus on secret codes and math. Sorry for putting the math in at the very end, but hopefully by the end of this 15 minutes, you'll feel more encouraged to incorporate math into your activities. Now, if you're anything like me, you may shy away from the math. You may favor the science and the engineering and the arts in the STEAM acronym over the math. And that's okay. All that means is that you don't immediately see the math connections to your existing science and engineering activities. At least that's the case with me. I just don't know enough about math. It just doesn't become immediately apparent to me that there is underlying math in my science and engineering activities. So again, that's kind of what we're going to do today. We're going to use an activity that you may have already done before. You may have seen done before. But we're going to highlight and pull out the math, and we're going to make the math the focal point in order to accomplish our activity. Okay, so we have three activities in one. The first one, before we actually jump into that first one though, I do want to provide some lingo for you so that you're familiar as I use these terms that may be new to you. All secret codes are going to start with plain text. That's the message that if you were to speak it or write it down, if you understood the language, you can read that message. Now, sending a plain text message across enemy lines or passing a note underneath the table when you're not supposed to and the teacher is watching, if it's in plain text, those people who aren't supposed to read the message are going to be able to read it. So you want to take your plain text and you want to jumble it up. When you jumble up a message, you are going to encode, E-N-C-O-D-E, encode the message. And the encoded message is going to travel in its encoded form using whatever transmission method that you would use. So for instance, when you send your credit card information online, you're going to send it across a wire, and the message that contains your credit card number is going to become encoded in your computer before it's sent out. Now, when that information and that message gets to its recipient, the recipient needs a way to decode the message, meaning they need to know how you encoded the message to start with so that they can decode it, break it down, and turn it back into plain text. So I'm going to use the words encode and decode. If you hear the terms encipher and decipher, those are synonymous for encode and decode. So you can use those interchangeably. Our first secret code that we're going to use does not have a whole lot of math to it, but it's a great way to introduce secret codes with your students. And the secret code is called Pigpen. Pigpen uses a cipher or a key that looks like this. Now, I encourage you to go onto Google and search for Pigpen. Pigpen is all one word. And if you just search for Pigpen secret codes, this will come up. You can write this out on a piece of paper. You can print out the templates. But just note that you'll have two checkerboards on the top. You'll have two X's down at the bottom. The thing that differentiates the two same up here is this is just a checkerboard. And then if you look closely, this checkerboard has dots down in the corners or down at the bottom. So that's how you're going to differentiate the two, let's say, between a B and a K. So a B is going to look like three lines with an open top, and K is going to look like those same three lines but with a dot down at the bottom. Okay, so now that you've had a 30-second intro to Pigpen and its cipher, let's go ahead and throw a message your way. Let's see if we can decode this message. Now, the message will look like a V, a backward C. This middle symbol, that's supposed to be a square, but you can see I need to work on my art skills. But in any case, that's a square in the center. And then we have a backwards L, and then we have sort of a C-shaped object there with a dot in the bottom corner. That's our message, and if you are decoding along with the rest of the participants, you may have seen the so appropriate message that I sent your way. This message that I have in my hand, if you decode it, it will spell out STEAM. So hopefully you see that by now. The V is the S, right? So that kind of looks like a V around the S. The C is our T right here, okay? And then so on. So this is Pigpen. This is a fun way to introduce codes with your students. And it's also an extremely accessible secret code. This can be done with kindergartners. So appropriate for all grade levels. The second secret code that I want to share with you is called the Caesar cipher. And to properly do the Caesar cipher, I encourage you to find a template online. You can just search for the Caesar cipher templates. You can download them in PDF form. Do a Google search and find that. You can also make these by hand, but man, they're so much easier just to print them out. So here's what it looks like. You've got two circles. You're going to hold steady the outer circle, and then you're going to spin the inner circle. And when you spin the inner circle, you are performing what's called an alphabet shift. Now, let's show you what the circle looks like before the alphabet shift begins. You'll see that the A is aligned to the A, the B is aligned to the B, and so on. So this is an alphabet shift of 0. In fact, if you look closely at our Caesar wheel, you'll see that there are numbers underneath the letters in the inner circle. When your A in the outer circle is aligned to the A underneath, that means that you have performed a 0 shift, or you have performed no shift of the alphabet. But now let's try turning our Caesar wheel. Let's perform a alphabet shift of 1. As we perform that shift, A becomes B. And if you look closely at our Caesar wheel, I'm trying to hold this steady so it shows up on the camera. You'll see the number 1 under the B in the inner circle. You performed a single shift of the alphabet, and A becomes B. B becomes C. So your plain text message, you're going to spell that out using the outer circle. And then when let's say you're writing the letter S in STEAM, let's go ahead and turn our Caesar wheel here. When you are writing that S, if you perform a single shift, anytime an S appears in your plain text, it will be written as a T in your encoded message. Now, the trick here, your recipient needs to know how many shifts you performed. If they receive a message and they don't have the key that's going to help them turn their wheel to the proper place and decode your message, they're going to have a very hard time figuring out what your message is. Now, there are only 26 combinations. There are 26 letters in the alphabet. You can only shift the alphabet 25 times, and then, of course, the 25th one is the original alphabet. So even if you don't know the key, it wouldn't take you very long to try 25 different combinations. So this isn't the most secure message, but it is a quick way to do some secret codes. Now, how do we incorporate math here? Well, you notice the numbers underneath the letters in the inner circle. What you could ask your students to do, if they didn't have a Caesar wheel, is to perform the shifts by adding a number to a letter. And you might say, add a number to a letter. How do you do that? Well, if you start with the letter S and you're trying, in your plain text message says STEAM, and you want to perform a alphabet shift of, let's say, 5, you will take the number S, or rather the letter S, and the number that corresponds to S, and you're going to add 5 to that. So I believe that number is 18. So you would do 18 plus 5. 18 plus 5, where does that bring us? 18, 19, 20, 21, 22, 23. 23 is X. So now if we perform a 5 shift in our alphabet, S will become X. So again, you don't necessarily need a wheel to do this. You can write this out in a long string on a piece of paper, and you can write your original alphabet, and then you can leave a space underneath. And depending on the shift that you perform, let's say it's 5, you will shift all of the letters over, and then you can start performing some basic math using letters, where you can say S plus 5, or T plus 5, or E plus 5. What do those letters correspond to when you add a 5, or when you shift by 5 in the alphabet? One quick tip for you as you use your Caesar cipher: if I go back to my original configuration, I recommend highly that you rotate your wheel counterclockwise. Why would you rotate it counterclockwise? When you rotate it counterclockwise, you kind of move up in the alphabet, meaning A becomes B, or A becomes C, A becomes D. If you were to rotate your inner circle clockwise, A would become Z or Y or X. And now there's nothing wrong with that, but there's just something that that just makes a little bit more sense when you move forward through the alphabet rather than bringing the letters in the back of the alphabet towards the front of your alphabet. So again, I recommend counterclockwise turning your Caesar cipher. So go ahead and find that template, print that out, use that. It's really fun. Our last coded message here is called it's called a decoder wheel, but you may also see this online as like a paper towel decoder or a toilet paper tube decoder, because you are going to use paper towel tubes, but don't stop there. See what else you have. Now, I'm in my garage, so I have all sorts of things that you probably don't have laying around, but I have a metal pipe. This is a conduit for electrical, and I have some PVC pipe that I can use. So if you don't have all of those things lying around, paper towel tubes will work, but you can really step up your game if you can find objects with different diameters. I wouldn't recommend going much further than the size of a paper towel tube, but if you can get things that are smaller, like, for example, a marker or a pencil, those are all fair game. I encourage you to bring those in and incorporate those into your next secret message. Okay, so here's what you need to do. Grab one of your paper towel tubes or dowels or markers or whatever you have, and you'll need to cut out strips of paper. Cut them out long ways. You need as much space as possible. You'll tape one end of your paper your paper strip to the towel tube, and then you will wrap the paper around so that the paper lines up nicely, right? So that it kind of looks like all the edges meet nicely. And of course, if you tape this down, it will look a lot cleaner and it'll be a lot easier to work with. So now this is where you're going to write your secret message. Let's see if I can hold on to the paper and show you. There we go. So you'll see that there are two strips. Because the diameter of our paper towel tube is wide, I was only able to put 2 wraps on with this strip of paper. But I can write a 2-letter message. I can put 1 letter here, and I can put another letter here. Hopefully, I'm doing that backwards. You'll put a letter, you get the idea. You put 1 letter on either side to spell out a message. Now, in the rest of the strip of paper, as it's wrapped around the tube, you're just going to put a bunch of random letters. Now, the only way that you can decode this message is if you have the proper key, meaning if you have the proper diameter tube that you will wrap your piece of paper around. So let me show you an example of what this looks like. I had written a message earlier and I placed it on my PVC pipe. Let's go ahead and make sure that it's oriented correctly for you. There we go. That's how it's supposed to look. My camera is backwards, so that's why I'm presenting things to you backwards. So I just put a bunch of random letters on my strip of paper as it was wrapped around my PVC pipe. But there is one location where I actually spelled out a message, and I'm going to have to rotate around to see if I can find it. There it is. I spelled out fun because I'm having fun doing math. Now, where is the actual math here? Well, in order to tell your recipient what key to use, meaning which diameter tube or marker or pencil or pipe to use, you can give them the circumference of that tube. Now, if your recipient has a strip of paper with a bunch of random letters on it and a circumference, they can now take the measurements, meaning measure the diameter of their tubes, to find out which one you used when you created the message, so that they can wrap their message around their paper towel tube and line up the letters in the correct way, right? So here's what your message looks like as you send it. It's just a long strip of letters. You can't really make out the message here, but as you wrap this strip of paper around the proper diameter tube, the letters will line up and you will get the correct message. So again, this is incorporating the diameter of your tube. If you want to take it one step further, you can have students calculate the circumference, which is the diameter multiplied by pi, or 2 pi r, which is using the radius, which you just have to multiply by 2 pi. But if you just use a diameter, you can go ahead and you can measure that diameter. In my case, my paper towel tube is 1.5 inches. 1.5 inches multiplied by 3.14, which is pi. That will give me my circumference. That will give me my distance around the tube. If I send my secret message right here, and I include the circumference of the tube, my recipient will know how to decode the message. We've provided the proper key. All they need to do is acquire the right tube in order to decipher it. So there's some math for you. Hopefully that makes sense. I hope that you are able to replicate this. I know it's sometimes difficult to share math activities, something that is very concrete when it's just being verbalized. But I really hope that this gave you some ideas on how to incorporate some math. I hope you're encouraged and you feel confident in your ability to do this. It is a lot of fun. And the best part, when your students walk out of your classroom, they're going to say, hey, wait a minute, you tricked me into doing math today. And if you ever get a student that says that to you, you know that you just had a very, very successful day as an educator. Thank you so much for joining our STEAM Bites workshop. I hope you've enjoyed this session and, of course, all of the sessions at our conference this week. Please keep in touch and let us know if you incorporate any of these activities with your students. We would love to see pictures or videos of these things in action. Thank you so much for joining and have a fantastic weekend.